So July 28, 2022 was World Overshoot Day. This day marks as the date when we had used all the biological resources that the Earth can regenerate in the entire year. In Sweden, where I come from, we have already passed the overshoot day for 2023. This means that if the world would consume in the same way as we do in Sweden, we would have already used all the biological resources that the Earth regenerates in 1 year already in April. My colleague that will be presenting in a bit comes from Pakistan. I will give you a moment to think about when you would guess that Pakistan's overshoot day is. For Pakistan, there is no overshoot day. Hence, Pakistan is a country that uses less biological resources, and with their consumption pattern, we would be in a much better shape. As you all know, we have huge inequalities in the world, and the way that we consume in the West is having environmental consequences in other places of the world. But this is not the main topic for today. We're going to talk about how we, as developers and builders, can contribute to a lower CO2 usage by architecting for sustainability. My name is Björn Eriksson, and soon you will also listen to my colleague Mohammad Sajid. We are both working as solution architects in the team in Stockholm at Amazon Web Services. The trend has been clear since 1971. We have gone from consuming 1 Earth to consuming 1.75 Earths per year. Today, we're going to talk about how you, as an API publisher, can start doing what you can start doing today to make more environmental friendly choices in your design and implementations of APIs. But let's be honest, we will not save the world by changing an API design. The only way we can make a real impact is by changing how we consume. There is a shared responsibility between publishers and consumers in general, and this also goes for publishers and consumers of APIs. It is a shared responsibility between the two to lower the CO2 impact of an API call. But if the publisher of an API does not create the levers for the consumers to use, then this shared responsibility becomes more a wall of separation. I'm going to give you an analogy that we will use during this talk. So in EU, road transport accounts for about 1/5 of all the CO2 emissions, and passenger cars is a major polluter. They are accounting for 61% of the CO2 emissions from EU road transports. When you drive a car, you sometimes need to have access to the full power of the engine, but at other times, speed and response time is not the priority, and you can choose to put your car into eco mode. Eco mode is a way for the driver, the driver, or the consumer, to tell the car, hence the producer, that you are okay with lower performance and thereby lower use of resources. To widen this analogy, you have the same options also in dishwashers, for instance, where you as a consumer can choose eco mode, and the program will take longer time to finish, but it will use lower water at lower temperature, and it will also consume less resources. But the result will be the same in the end. So the question is, does your API have an eco mode? Let's bring that analogy with us now when we start talking more about API design, and I will hand the mic over to Sajid.
Thank you very much, Björn. It's pretty simple. We know we are consuming more resources than our planet has to offer. We are polluting it, warming it up, burning it, flooding it, and ultimately killing everything on it. We do this mainly by burning fossil fuels to generate the electricity we need to power the things we want. And obviously, IT is part of the problem. In fact, it's quite a big part of the problem. So by the end of this short session, you will know what is carbon efficient software, how to calculate, or I should say, estimate the carbon impact of a software, and the idea of eco mode in APIs. And finally, we want to make sure you leave with more resources you need to keep learning. So back in 2021, web traffic exceeded 2.8 zettabytes. In 2.8 zettabytes, you can store 21 trillion MP3 songs, and one would need to be alive for 119 million years to listen to all those songs. And most of this traffic is going through or was going through APIs. So as an API developer, we have a huge opportunity to make our APIs carbon efficient. But what does carbon efficiency means? Well, it means emitting the least amount of carbon possible. So how can we reduce the carbon emission? So there are 3 activities that can reduce the carbon emission of an API or any software in that matter. So the first one is energy efficiency, carbon awareness, and hardware efficiency. So let's break them down, like what does each mean here. Energy efficiency is all about consuming the least amount of electricity to run our APIs or any other software. Carbon awareness means doing more when the electricity is clean. And what does it means actually? What does clean electricity means here? So it means not electricity which is not produced by burning fossil fuels, and doing less when the electricity is dirty. And the third one, hardware efficiency, that involves reducing the embodied or embedded carbon in the hardware where our APIs or any software is running. Embodied carbon is the total greenhouse gas emissions generated during production and disposal of a device or a hardware or any server that we are running our API on. So what is the first thing that we can do? In order to make our APIs eco-friendly, we have to make sure we host them in a region that is powered by clean energy. And most public cloud vendors are investing a lot in creating sustainable data centers. And do you know Amazon is the largest corporate buyer of renewable energy? So what we can do for running APIs in an eco-friendly manner, we have to focus on at least 3 aspects. There are more aspects, but at least 3 we can discuss today. And these are network, compute, and storage optimization. So how can you do the network optimization? You can reduce the network traffic by your API, of your API by keeping the data closer to your API consumers. So for example, if you use microservices architecture and 2 or more microservices are highly coupled, consider co-locating them to reduce network congestion and latency. This will also reduce, as a side effect, I would say, a good side effect, the cost of your API as well. We can also reduce the amount of data we transfer between 2 services. Similarly, we can use caching mechanism whenever possible and use energy efficient protocols like MQTT. Secondly, you can increase compute utilization by right-sizing the infrastructure required to run your APIs. You can destroy or completely turn off non-production environments after use. You can easily recreate the environment that you destroy with the automation or CI/CD pipelines, or writing it in an infrastructure as a code manner. Consider delaying asynchronous background processes. Consider delaying asynchronous background processes to run when the compute resources are idle. You should also consider running any resource-intensive workload in a region with the lower carbon intensity. You should also think about performing compute-demanding tasks in the cloud. What about the storage or database optimization? You can optimize storage by reducing the amount of data you store and deleting the data that you don't need. If possible, relax the consistency requirements on your databases and embrace eventual consistency. By the way, eventual consistency does not mean lack of consistency. It means full consistency after a minimal replication lag. And finally, choose energy-efficient file formats to store the raw data. Now let's look at some architecture patterns that you can use to reduce the energy consumption of your APIs or any other software in that matter. You can use queue-based load leveling to process multiple messages in a batch during a low carbon intensity time. So for example, you can batch the messages and also move the processing to a different time rather than processing them immediately. You can also use event-driven architecture. So I would suggest prefer event-driven over request response patterns to avoid blocking the client while waiting for the API responses. If you have energy inefficient legacy systems, make sure to isolate them using anti-corruption layer pattern to avoid spreading inefficiencies in other parts of the system. So far, we have spoken about what an API publisher can do to make APIs eco-friendly. My colleague Bjorn already spoke about trading performance with fuel or energy efficiency in cars and washing machines, and that choice is for the consumer to make. Why don't we let our API consumers decide whether they want to enable eco mode while consuming our APIs? For many users, immediate response might not be a priority. They can wait to get detailed report via email until later time. Similarly, many users might be happy to generate that monthly report at a time when energy is clean. So how can we enable the eco mode? We can enable eco mode by introducing a new query string or HTTP header parameter that users can pass on. We can even implement a standard endpoint in our APIs to configure these settings and get energy consumption data from the API. By the way, we can also return the carbon emissions back to our API callers on each request or via a dedicated endpoint. In this way, API consumers will be aware of their carbon impact of using your APIs. But question is, how can we measure the carbon emission of a software and why it is important to measure even? As Peter Drucker said, if you can't measure, you can't improve. What gets measured gets improved. What gets measured and reported back gets improved exponentially. That means we should report estimated carbon emissions of our APIs back to our API consumers. But again, question is, how do we measure the carbon emissions of an API? Software carbon intensity is a method for scoring a software system based on its carbon emissions. It's a methodology for calculating the rate of carbon emissions for a software system. In our case, that software system is obviously an API. So let's see what is involved in calculating software carbon intensity. We just need to know the RIME, R-I-M-E, of an API. But what is this RIME? As I said, this SCI, software carbon intensity score, is the rate of carbon emissions, not a total carbon emissions. So in this equation, E is the energy consumed by the APIs measured in kilowatt hours. I is the carbon emitted per kilowatt hour of energy, and we measure it in grams of CO2 produced per kilowatt hour. Next, we have M. M is the embedded carbon, that is amount of carbon produced during creation and disposal of a hardware device. By the way, you can get this information through different public cloud providers if you're running your APIs in cloud. What about the R? R is my favorite. This is the secret sauce of the equation. This is how your API or any software scales, for example, per user, per API call, or even per device. Today, there are various tools available to measure the inputs to the equation. And most cloud vendors, as I already said, share the sustainability information and energy consumption for the hardware used in their data centers. So if you are running your APIs in the cloud, you can use third-party APIs. For example, here you can see one example called Climatic APIs to calculate the carbon footprint of the cloud resources you use for running your APIs. So with this third-party API, you can also see the energy consumption per region, like which region your software is running. Now, if you want to learn more, please take a picture of this entire slide for referencing later. I mean, these are the resources where you can learn more about this topic. We need to do something right now. Even if our industry is responsible for just a little percentage of the overall global carbon emissions, we have the opportunity to not only reduce our emissions, but also help other industries reduce theirs. We have a responsibility. We do not inherit the earth from our ancestors. We borrow it from our children. It's been a pleasure. Thank you very much for today from both me and my colleague, Bjorn. Thank you.
Thank you.